All right, we are still solving triangles, but instead of the law of sines, we're going to deal with the law of cosines today. An uglier formula, but an easier problem both conceptually and just in terms of, just cranking it out. It's not too bad. Let's dive in. Quick reminder from our notes from our last video, kind of when to use the law of sines. The law of sines, if you're given one side, and that one side is between the angles or not between the angles. Either way, given one side, you dive into the law of sines. Easy peasy problem. Now, when you're given two sides and a non-included angle, that's the ambiguous case. So today we're going to focus on two sides and the included angle, and then all three sides. So, of course, you're given all three side lengths. Easy. You dive into the law of cosines. If you're given two sides and an included angle, we're going to draw some sketches to see what that looks like, then you use the law of cosines. So it's pretty easy to determine when to use the law of cosines and when to use the law of sines, and we'll mix it up and so we can kind of see what that looks like. All right, so the formula. So the formula for the law of cosines, obviously a little bit more involved than those ratios for the law of sines. I like to memorize just one. Put a dot by it, because to me this looks like the Pythagorean theorem. So here's how I just kind of memorize the formula. Okay, so c squared equals a squared plus b squared minus 2 is part of the formula. 2 times a times b times cosine of the angle opposite the side that is solved for. Okay, so that's kind of the pattern. So if you're setting a squared equal to everything, then the angle is a. B squared, the angle is b. C squared, the angle is c. And then everything else within the right-hand side matches up. So a squared, c squared, 2ac. B squared, c squared, 2bc, etc. Okay, so 2 points to make very clear. When you use the law of sines to find an angle, this is important. If you use the law of sines to find an angle, try to make sure that you start with the shortest side, because when you're using sine inverse will never spit you out an obtuse angle. And if you're using the longest side to find the angle opposite, right, it sometimes should be an obtuse angle, but the law of sines will never give you an obtuse angle. So I'm going to make a mention of that as we use that fact, because when you use the law of cosines, you then have to go back to within the problem using the law of sines. So we'll see that. I'll make that clear when we use that. So when using the law of sines, if you have to choose between two sides, always go with the shortest side. Now why? We'll see that when we get there. All right, but if you're going to use the law of cosines to find an angle, then always use the longest side, because cosine inverse will actually give you an obtuse angle. So we're going to see we're going to see a couple of examples where we dive straight into using the longest side. For example, if C is the longest side, we would put C here so that we can find angle C. If C is the longest side, C is going to be the largest angle. And the largest angle sometimes is obtuse. Cosine inverse will spit out an obtuse angle. Sine inverse will not. So those are 2 tips when you're solving for triangles. All right. If you're using the law of sines to find an angle, then try to use the shortest side that's opposite the angle you're trying to find. If you're trying to find an angle using the law of cosines, go for gold. Start with the longest side when you're trying to find the largest angle opposite that side. All right. So these 2 pointers, these tips will make more sense when we dive into the examples. Right, the first example, okay, so when you're given sides and angles, if you're just given 3 sides, no diagrams necessary, right? But if you're given 2 sides and an angle, you want to know, right, is that 2 sides and the non-included angle, or is that 2 sides and the included angle, because this is law of sines where this is law of cosines. Now, I see xz and then not x or z as an angle. That's going to be this case. Let me draw an image and kind of show you why. So we have triangle xyz, x, y, z. This is arbitrary. It doesn't matter where you call x, y, and z. But x, right, if this is angle x, then opposite angle x is side x. So there's 5. 8 is the length of side z. That's going to be opposite angle z. So there's 8. And then you can see that y is between. This image is called side, angle, side, 2 sides in the included angle. Anytime you're given 2 sides and the included angle, you're going to dive straight into the law of cosines, and you're going to try to find side y first. Okay? So here's the law of cosines. I'm going to write it in its most basic form, and then I'll never go back to this again. So I have c squared equals a squared plus b squared minus 2ab, right, times cosine of angle C. Now in this case, I'm trying to find y. Okay, so this is going to be x squared plus z squared minus 2xz times cosine of y. In this problem, if you're given a side, angle, side, then you will literally be given everything you need to straight plug in and use this formula as it was designed to be used. Okay, so we're trying to find y. So in the law of cosines, we'll find y squared first. X, so we have 5 squared. Once again, I'm doing a lot more detail in the first example. Moving forward, I'll move through these much faster. Times 5 times 8 times cosine of the given angle 77 degrees. So you literally just type all of this in the calculator carefully. Make sure that your mode for the trig functions, make sure your mode is degrees and not radians. So y squared is going to be not a pretty number, so 71.0039. Then you take the square root of both sides. So the square root of 71.0039 is, well, remember there are 2, but we're only concerned with the positive one. So 8.426, which is approximately 8.43. Okay, so remember we're solving for a triangle, so I'm going to go ahead and kind of organize my thoughts. On the quiz, on the quizzes and the test, you'll see x, y, z, angle x, angle y, angle z. So we already knew 77. We knew that x was 5. We knew that z was 8. So it's kind of nice when you organize your thoughts, you can actually see side, angle, side. It kind of zigzags. Okay, and we just found that y was 8.43. Now, in this problem, I know that y is the longest side. So I already know that y is the largest angle. But in general, if I'm going to use, now I'm going to have to go back to using the law of sines. So once you know 3 sides and an angle, you have to now use the law of sines. So I always, when using the law of sines, just get in the habit of using the smallest side. Once you know all 3 sides, I'm going to now use this information to use the law of sines. So the question a lot of times is, if the law of cosines is an easier method, why do we learn it after the law of sines? Well, because within the law of cosines, you're going to use the law of cosines one time to find one part, then you have to revert back to the law of sines. So in this case, I dive straight back in. So I have sine of angle x over x, sine of y over side y. So I know sine of x is, I don't know, that's what I'm trying to find, is angle x. I know that the side length x is 5. Side length y is 8.43 sine of 77 degrees. So sine of x equals, using that, nice cross multiply and divide shortcut, 5 times sine of 77 degrees divided by 8.43. Hopefully you're utilizing, that shortcut. Take the sine inverse of both sides. So x will equal sine inverse of all that. 5 times sine of 77 degrees over 8.43. Remember, you can approximate, rewrite, approximate, rewrite. I don't like to do that because then the accuracy of my solutions is off. Which gives us approximately 35.304 or 35.30 degrees. Okay, so let's go back to where our original work was. We know that x is now 35.30. So 35.30 degrees. To find z, you now subtract. So 180 minus those two angles. So 180 minus 77 minus 35.3 is 67.7 degrees. Boom, we have solved the triangle. So just a reminder, when you're given two sides and the included angle, you dive straight in. So that's A, just plug it in the calculator carefully, take the square root of both sides, find the third side, and once you know the third side and one angle, you're back to the law of sines. Okay, so this was our side, angle, side example. Ugly formula, not a bad problem. Okay, all right, example 2. Now in this problem, I'm not going to draw a diagram because I notice M, A, Y, M, A, Y, they're all sides. So the side length M is 90, A is 70, Y is 40. So we need to find the measure of angle M, the measure of angle A, and the measure of angle Y. Now, once again, if I'm going to use the law of cosines to find an angle, I'm going to find the largest angle. Now, if there's going to be an obtuse angle in this triangle, it will have to be opposite the side that's 90. So just to remind you, if I have one really long side in a triangle, let's say that's 90, and the other two are significantly shorter, in this case 70 and 40, I know that opposite 70, that's acute, and opposite 40, that's acute, but I know opposite the longest side. As this angle gets larger, so as this angle gets larger, the opposite side gets longer. So if there's going to be an obtuse angle in this problem, it's going to be angle M, right? There might not be an obtuse angle in this problem, but if there's going to be one, it's going to be M. Dive straight into finding M for law of cosines, meaning I'm going to use M squared equals A squared plus Y squared minus 2AY times cosine of angle M. Okay, so if I'm trying to find angle M, I start with length M in the formula. And then you just plug everything in. So the nice thing about this is I know M, A, Y, but I'm going to ultimately solve for cosine of M. So there's a little bit of arithmetic here. There are common mistakes, so be really careful and watch the details here. So I'm going to have 90 squared equals 70 squared plus 40 squared, plus 40 squared. Uh-oh. Just replaced the battery in my pen. I don't know what's going on, but we'll keep on going. Okay, so A and Y times cosine of M. All right, so I really don't need this diagram. Let me kind of get that out of the way. Okay. So now, here's where I say, be careful. You're gonna find this value, minus, this is a term, so you can't subtract. That's where you have to be careful. Lots of careless mistakes happen here when I teach this at the college level. Now, you guys, I'm just saying, it's accelerated pre-calculus. You guys learned a lot of the skills that my college students did not learn. You learned those skills in middle school. So I haven't been seeing a lot of the carelessness and silliness in terms of just not understanding how numbers work with you guys. But just to be careful, 90 squared is 8100. And then go ahead and find 70 squared plus 40 squared, right? So that's going to be 6500. And then minus, go ahead and find 2 times 70 times 40. 5600. So 5600 times cosine of m. Now here's where my college students, not many, but you know, out of a class of 30, I'd have 5, 6, 7, 8 make this mistake. Okay, so be careful. You cannot subtract, of course, because I don't know what 5600 times cosine of m is. So this is where you subtract 6500 from both sides. Okay, and that's going to leave you 1600 equals negative 5600 cosine m. Divide both sides by negative 5600. Okay, so negative 0 point, and I'm going to keep 4 decimal places. 2, 8, 5, 7 equals cosine of m. And here's what I would do. You can even, you don't have to, but I would, if you want to be really accurate, you can leave this fraction alone, meaning when you divide out the negative 5600, and generally I do this. You don't have to, but and most instructional videos I've seen don't do this, but I think it's nice to just leave it as this. Okay, now of course you can reduce the fraction, but remember this is all intermediate, right? I'm trying to find angle m. So you can approximate, right? 1600 divided by negative 5600, or you can just leave it alone, and then you're going to take the inverse of cosine on both sides. So this is what I'm interested in. So negative, as long as you put in one negative, doesn't matter where, numerically. Okay, so this is what I'm trying to find. So personally, I don't like to write a bunch of decimals until I have to. So I like to manipulate the equation completely, getting m by itself, solving for m, then just type all this mess in one time, and then my answer is as accurate as it's going to be. So let's find the angle. I will tell you this, anytime you find cosine inverse of a negative, so let me just remind you guys, cosine inverse lives here and here. If you're plugging in a positive value, you're going to get an angle between 0 and 90. If you're finding cosine inverse of a negative, that means the angle actually is going to be obtuse, right? We thought maybe angle m is obtuse. Cosine inverse of a negative will actually give me an obtuse angle, an angle between 90 and 180. So, just so you know that. So if you get down to this point and you have a negative over a negative and this fraction is positive, then that means the largest angle in the problem might be 82 degrees, which is acute. Okay, so just a little bit of background information that you don't necessarily need to know, but it's helpful to for your numbers to say what they should in terms of lengths and angles. So cosine inverse, this gives me 106.60. So that gives me 106.60. Once again, cosine inverse will give you obtuse angles, sine inverse will not. So if you're trying to find an angle, start with the angle that will be the largest angle, and then you once again you revert back to the law of sines. All right, so we know an angle, we know two sides, so now I'm going to use the law of sines, and at this point it really doesn't matter. I've already found my largest angle, so both of these angles will be acute. The law of sines will give me either one. So let's find. So I have sine m over m equals, and at this point it doesn't matter, but just to kind of get in the habit, I'm going to use the shorter side, sine of y over y. So sine of 106.6 over 90 will equal 40 is y, sine of y. So we cross multiply and divide, so sine of y will equal, so sine of y equals 40 times sine of 106.6 over 90. Therefore y equals sine inverse of that, which gives me approximately 25.21 degrees. So angle y is 25.21 degrees, and of course you subtract the two angles you know from 180, and you're left with 49.19 degrees. And then just do a quick check. I always do this. My shortest side is opposite my smallest angle. My longest side is opposite my largest angle. Quick check, all is well. Boom. Okay? So just a reminder, if you're given three sides, start the formula with the longest side. That means you're finding the largest angle. Cosine inverse will give you obtuse angles. Sine inverse will not. All right, last example. Try this on your own. Take a minute. Take a minute and try to do what I just did. All right, so you're given three sides again. There is a longest side, that's 9, and a shortest side, that's 5. And try to find angle M. So pause the video if you choose. It's just good practice. Pause the video, see if you can find angle M, and then check your work by my work. All right, so very similar to the last example you saw for M. Cosine inverse of a negative. Once again, I get another obtuse angle. So yes, angle M is obtuse. So we have 95.74 degrees. Now, like the last problem, take these two values, M and M, take T and T, and find angle T. Pause. Try this on your own, and then check your work by my work. Right, and there we are. Check your work. Check my work. So angle T is 33.56 degrees. And then to find angle N, you take 180 minus the two angles you do know, 50/70. And there you are. You've solved. All right, so my hope is, this was certainly a lot shorter than the law of sines video. Don't forget, law of sines, you need to know the proof. Law of cosines, you just need to be able to apply to solve triangles. And then we'll start doing some mixed practice and word problems like application diagrams. Given these three parts, use the law of sines or the law of cosines to solve. So that's when you really kind of start to differentiate between. There are really four problems, two of which are law of sines, two of which are law of cosines. All right, keep practicing and be ready to present in class. All right, be safe, guys.